Welcome back, developers and system administrators. Today, we're diving into Docker, the technology that has revolutionized how we build, ship, and run applications. If you've ever faced the classic, "it works on my machine" dilemma, Docker is the solution you've been waiting for. By packaging your application and all its dependencies into a standardized unit called a container, Docker ensures your software runs consistently anywhere, from your laptop to production servers. Think of Docker as the shipping container for software. Just as physical containers standardized global trade, Docker containers standardize how we package and deploy applications. This consistency eliminates environment mismatches and streamlines your workflow, making deployments predictable and reliable. Let's explore how Docker achieves this and why it's become a cornerstone of modern development. To truly appreciate Docker, it's important to understand how it differs from traditional virtual machines. Virtual machines run entire operating systems, making them heavy and slow to start. Each VM includes its own OS, libraries, and applications, which leads to significant overhead. In contrast, Docker containers share the host OS kernel, making them lightweight and fast to launch. Containers isolate applications at the process level, reducing resource consumption and improving efficiency. While VMs offer complete isolation and are ideal when you need different operating systems, Docker excels at deploying applications and microservices that need to run consistently across environments. This fundamental difference is what makes Docker so powerful for modern software development, enabling rapid scaling and simplified management. Let's break down the core concepts that make Docker work. At the heart of Docker are images and containers. Images are read-only templates that define the application and its dependencies, built in layers for efficiency and stored in registries like Docker Hub. Containers are runnable instances of these images, providing isolated environments for your applications. They're ephemeral, meaning you can create and destroy them easily, and they all share the host OS kernel for efficiency. The Docker file is a blueprint for building images, specifying everything from the base image to the commands needed to run your app. With simple Docker commands, you can build images, run containers, and manage your entire application lifecycle. This approach brings consistency, isolation, portability, and efficiency to your development workflow. Ready to get hands-on? Let's walk through containerizing a simple web application. Imagine you have a basic Flask app in Python. With just a few lines in a Docker file, you can package your app, its dependencies, and instructions for running it. You'll build the image using Docker build, then run it with Docker run, mapping the necessary ports. In seconds, your app is running inside a container, isolated from the rest of your system. This process not only simplifies deployment but also ensures that your application behaves the same way on any machine. Whether you're developing locally or deploying to the cloud, Docker makes it easy to move from code to running service. Mastering Docker means knowing the essential commands for managing containers and images. You can run containers in the background, list running or stopped containers, stop or remove them, and view logs for troubleshooting. Image management is just as straightforward. Build images from Docker files, list or remove images, and pull or push images to registries. Useful flags let you run containers in detached mode, map ports, mount volumes for persistent data, set environment variables, and even run interactive shells. System commands help you monitor Docker's resource usage and clean up unused resources. With these commands, you have full control over your containerized environment, making development and operations seamless. As your applications grow, you'll often need multiple services working together, like a web app and a database. Docker Compose makes this easy by letting you define multi-container applications in a single YAML file. You can specify each service, their images, environment variables, volumes, and how they connect. With simple commands, you can start, stop, and manage your entire stack. Compose ensures consistent environments for development and production, simplifies networking, and handles service dependencies. Whether you're building a microservices architecture or a full-stack app, Docker Compose streamlines multi-container management and keeps your workflow organized. Docker isn't just for simple apps, it powers real-world solutions across industries. In microservices architectures, each service runs in its own container, making scaling and updates easy. Continuous integration and continuous deployment (CI/CD) pipelines use Docker to ensure consistent test and deployment environments. Databases like PostgreSQL can run in containers with persistent storage, while web servers and proxies like Nginx are easily deployed and configured. Following best practices like not running containers as root, using minimal base images, and scanning for vulnerabilities keeps your deployments secure and efficient. Docker's flexibility and power make it an essential tool for modern development teams. Getting started with Docker is easier than ever. Install Docker Desktop for Windows or Mac, or Docker Engine for Linux. Begin by containerizing a simple web app, running a database, or setting up a multi-service application with Docker Compose. As you progress, master basic commands, learn Dockerfile best practices, and explore orchestration tools like Kubernetes. Docker has fundamentally changed how we develop, ship, and run applications, emphasizing consistency, portability, and efficiency. The best way to learn Docker is by doing so. Start containerizing your projects today and experience the benefits firsthand. Great applications deserve great packaging, and Docker delivers exactly that.
Subscribe to Knowledge Hub, like this video, and tap the bell so you never miss what's next.